hearty welcome to all participants for the final session of this workshop. I consider this as a rare privilege and honor to introduce Professor L.M. Patnaik to all of you. Professor L.M. Patnaik is an adjunct professor at NIAS and INSA senior scientist. Professor has held the position as a Vice Chancellor of DRDO from March 2008 to August 2011. Prior to this, he was a professor with the Department of Computer Science and Automation at Indian Institute of Science, Bangalore. His research interest covers broad areas like parallel and distributed computing, computer architecture, high-performance computing, machine intelligence, etc. He has several peer-reviewed international journal and conference publications, books, reports in these areas. One of his research papers in the area of adaptive genetic algorithms has been cited over 3,589 times, and a survey article on genetic algorithm over 2,368 times. He has also served as a president of Advanced Computing and Communication Society and the Computational Intelligence Society of India. Professor has received several numerous awards. For example, especially the Dr. Vikram Sarabhai Research Award in 1989, the Dr. Ramlal Wadhwa Award for the year 1992 for his outstanding contributions in electronics, informatics, and automation. So on behalf of NIAS CSP, I would like to welcome the distinguished Professor Dr. L.M. Patnaik. And also, I would like to request all the participants to kindly mute your audio so that we can listen to the speaker very clearly. And also, please type your questions in the chat box so that after the presentation, we will have a discussion. So thank you all. And I request Professor to kindly take over the session.
Thank you, Dr. Hari. So are you able to see? I have shared the screen.
Yes, sir. Yes, sir. Absolutely.
Yes, sir. We are able to see. Yeah.
No problem. Okay.
No problem.
Let me see. This is to advance. Okay. At the outset, I would like to thank Professor Sangeeta Menon and Professor Nitin Nagaraj profusely for having given me this opportunity. I was listening to the wonderful presentations of Professor Nitin, Professor Tilak, and Professor Snehanshu, all the talks. They have in detail discussed everything. They have discussed, debated, dissected. They have done everything. They have essentially covered almost all aspects of AI, starting from the history, learning algorithms, computational aspects, ethics, bias, analytical aspects, mathematical, and on the top of that, Madam Professor Sangeeta Menon has given wonderful philosophical interpretations related to consciousness, message, and all that. So there is nothing left for me to talk about it. And we, of course, in any seminar series, being the last speakers, you have this unfortunate scenario. You can't help how I wish the clock ticked fast and went up to 12:40 at 12:30, 12:40, and I can say I can log out and thank you all, get off from this embarrassing situation. But having committed, I have to keep you busy for the next 45 minutes and an hour. So I will give a sort of synthesizing overview of what the topic is. We will not get into all the details of learning algorithms, get into any mathiness or details of maths and all that thing. I was for a while not sure what title I will give, looking at other three titles. I said there have been the recent renaissance in AI, a lot of progress, but then there are a lot of promises also. It is creating a revolution and all that thing. Notwithstanding these claims, still we find there are some bottlenecks, failures, limitations. So is it really a revolution or still in the evolution process? One has to see, okay? I do not have an answer. I think we need to debate and open and see. That is what I said. So what I will do in the initial first few minutes, very quickly run through some of the known aspects which have been covered, the historical things, because I have said AI, the renaissance, how it has recently progressed, and it has witnessed what we call the AI spring and AI winter. It has witnessed both. There have been ups and downs and all that. Okay. Of course, pardon me, I forgot to thank Dr. Hari, who took the trouble of introducing me, and Dr. Niharika has been doing a wonderful job of coordinating this series of talks. Thanks to both of you. I will not give a formal definition of AI. As all of you know, it started sometime way back in 1956, where the well-known professor, very famous Professor John McCarthy, coined the word AI is the science and engineering of making intelligent machines, especially intelligent computer programs. Probably Professor McCarthy was very smart, very intelligent. He used the word intelligent and left it there. Because to define the word intelligent is pretty tough. If we go around and ask the audience what is precise definition of intelligent, as I say, we will get the minimum number of definitions which will equal to at least the number of people attending the seminar. Each one of you will have different perception what is intelligent is. So intelligence, natural intelligence, artificial intelligence, consciousness, these are pretty tough things to define what should be the attributes. So unless you know precisely what it should have, there is an agreed upon universal definition. We can't be talking about machines which have died and whether they satisfy all the things. There have been many definitions, the exciting new effort to make computers think and machines with minds. In the full and literal sense, the study of computations that make it possible to perceive, reason, and act. Most of all these things we as human beings do. So essentially, the activities we associated with human thinking, activities such as decision-making, problem-solving, learning, and all these things. And you had wonderful exposition, discussions, and learning algorithms, how it is done, what are the attributes, and all. There were discussions about weak AI, strong AI, and artificial narrow intelligence, general intelligence. They can solve a specific problem like medical diagnosis, playing a game of chess, okay, or playing a game of Go, but probably they can't do anything. But we as human beings, we can write poetry, we can look at a prose, we can write a paper, do experiments, okay. At the same time, maybe play a game, learn something. A machine may not be able to do that. So artificial general intelligence is something like human beings doing everything. We are still nowhere near that. Nick Bostrom and others have been talking about the superintelligence. You will find excellent reports on the web. That is the problem of singularity. The conjecture, the argument is if machines, both in terms of their hardware power and the software capabilities, increase like this exponentially, what will happen? A time will come, probably they will match our intellectual capabilities and might overtake us. So that is the fear lurking somewhere. Will it happen? But then there are arguments pro and against. You will find that computer scientists say, how is it possible? We develop the code, we develop the algorithms, we write the code, we debug the code, we develop the learning algorithms. How is it possible? But then there are possibilities. People say, yes, it can accumulate its knowledge, argue, and keep doing that. So that is a different aspect. Is outside the scope of this talk. It will take several hours. If you look at the timeline of AI, starting from 1943, like Professor Nitin was talking yesterday about neural networks, that is the network of neurons, Makula Pitch talked about that. Then there is 1950, Asimov's iRobots. Then 1950, the famous Turing machines, and the Turing's work was there. He started a question, can machines think? There was a celebrated, very important work. And 1956, where there was a Dartmouth conference, I said Professor John McCarthy and a group of his friends, few of them coined this word. We had 1961, GM Robotics production line, then ELISA chatbot. A number of these things you find, back propagation, and somewhere autonomous cars, 1986. IBM Deep Blue beating Kasparov at chess, 1997. And DARPA demonstrated the autonomous vehicles challenge. Then the IBM's Watson machine beats Jeopardy champion. Then we had Siri, Cortana, and all that thing. We had DeepMind's AlphaGo. And we talked about autonomous machines. In 2018, there was first wave of robotic taxis start playing. So when we talk about an AI system, the attributes, as you have been listening for the last couple of days, it should learn from experience like we do. Users, they learn to reason, recognize images, should solve complex problems, understand language, its nuances, which is very difficult. We had some discussion about natural language processing. There are some pronoun mix-ups and all that thing. It is difficult to come up with something even it creates some perspectives. They should have these abilities. So the components of AI are essentially building systems that, as we said, can do intelligent things. So for our discussion, when we said intelligent, what the previous slide talked about, those are the operations. It has certainly a component of natural language processing, build systems that can understand language, syntax, semantics, its nuances. And machine learning is an important component of that, building systems that can learn from experience like we do. We have supervised, unsupervised, reinforced. You listen quite a bit about that, deep learning, and recently generative adversarial neural networks. And neural networks, as was mentioned yesterday, they're a biologically inspired network of artificial neurons. And in deep learning, they're building systems that use neural networks of a large set of data. In backprop, we talked about number of layers, but then in deep learning, as you heard, one of the advantages is you don't need features. We talk about supervised, unsupervised. Without features, you can stay, give the image, you can stay, give the speech, you can input the object. The different layers, the filters automatically update the coefficient. They start to learn different parts like the color, edge, surface, pixel details and all that. So it has a component of natural language processing, automated reasoning, machine learning. When we talk about AI, generally intelligence AI, it is not that learning is the only component. We need to talk about how do you represent knowledge. You have to use logic, okay, first order logic, propositional calculus, okay. How do you argue with this knowledge? Reasoning, because when you talk about reasoning, one has to use some logic. So knowledge has to be represented. In computer science, we talk about production rules, frames, semantic networks. There are different forms of knowledge has to be represented. So when we talk about AI totality, it has different components. Learning is only a small part of it. By far, as you can see, this statement says from a famous person, the greatest danger of AI is that people conclude too early that they understand it, okay? Because it's such a complex thing. We have, in an AI continuum, assisted intelligence, augmented intelligence, autonomous intelligence. In autonomous intelligence, you leave everything to the machine. Okay, it takes the decision, it acts, but we are far from that. What we have is essentially augmented intelligence. It assists the human operator. Finally, the decision is taken, whether it is medical diagnosis, healthcare system, or flying an aircraft. There is even a fly-by-wire. We talk about the pilot puts it into the autopilot, fly-by-wire to some extent, but there is a pilot who is overseeing. And we know some of the famous tragedies, accidents which happened recently because the pilot could not overtake or override the control of the software. The machine had something, there was nosedive and there was accidents. You have heard about these stories when you leave it to the software completely. What happens? There are many applications of AI you have heard during the last couple of days, excellent applications starting from old to the present ones. In medical diagnosis, talk about breast cancer, most commonly diagnosed cancer in women. In 2018, 2.1 million new cases have been detected. Mammography is the gold standard using image processing techniques, extract features. You do that. Diabetic retinopathy, 400 plus million diabetes at risk. And you essentially look at retinal fundus images, analyze that using this. There were many talks, many discussions I had from different angles about the recent pandemic, COVID, how it can be used. There are many examples where AI can be useful, but still we have not come to a scenario even for COVID or a pandemic, AI doctor. It has not come to that stage. But still, it can help because we have several hundreds and thousands of patients, limited number of doctors, limited number of healthcare professionals. So can it help to decide where PPEs and ventilators should be set? The ventilator usage is something quite tricky because there is a pumping mechanism, air has to be pumped. So there is a natural pumping mechanism already. Okay. So how this should do against that, how we should synchronize, it is a very tricky affair. If it is not synchronized properly, it can lead to some fatal problems. So this is a complex problem where there are some measurements, some controllers, some control algorithms. One can use AI neural networks for this thing to develop a very smart, efficient ventilator controller algorithms, because we do not have that many number of doctors and nurses who can be standing by the side of the patient, physically monitoring. You have leave it to the machine automatically. The machine has to do the settings, and depending on that, it has to control the flow so that the patient doesn't get into problems. This is a very tricky thing. So AI can come very handy in that. And you take data from the past patients, those who had some morbidities like heart diseases or cancer, some of the problems, what type of history they had, how the ventilator functioned. So can the setting be learned and used in some other cases? So a lot of data has to be collected. As you have said, we will see a little bit later, IBM has said several gigabytes of data a person essentially collects during his or her lifetime when it comes to healthcare. How can strain be eased on doctors? Process, okay? Physicians can keep off from danger, can do more therapeutic work, do less paperwork. AI helps in early diagnosis, providing treatment at an early stage, providing best training to doctors and students. Because this is something important. The fresh doctors who have to be trained, who have to learn, I think you can develop some nice training methods, algorithms, tools can provide more predictive and preventive healthcare for this. Can help in early warning of alerts, tracking and prediction. Data dashboards, as you see, even in India, Microsoft and some of them have come forward to help the government to create data dashboards for this, because you collect huge amount of data. How do you present that, analyze that, even forgetting about forecasting, diagnosis and prognosis, treatments, cures and all. Russia is using a combination of an app and a QR system to track infected people and control their movement. Computer vision and robots will be used for social control, that is distancing. Deep neural networks with X-ray images have been used to detect COVID-19 cases. See, one can talk about PET, other imaging techniques, MRI and all the things, but X-rays have been found to be quite cheap, affordable in many places, and people have used it for COVID-19 diagnosis. And with about 19 convolution layers, 5 pooling layers, this has achieved 98-point accuracy in detecting the cases. This has been tried. AI systems at present are constrained by the lack of data, because you have data, but particularly for this case, you need different type of data, demographic things, different cultural habits, food habits, gender. There are many things, many claims you hear, okay? So to substantiate that, you need tremendous amount of data analysis. You heard something in the last talk, excellent presentation on big data. To use that, essentially IoT, big data, the learning algorithms, AI, they all swim together, okay? Because AI needs data to process, do that. You need big data techniques for that. After infections are gone, surveillance and other data may be misused, so one has to be very careful. AI can be handy, useful, digitizing the food quality, taking images, from that process the images, find out what is good quality, what is bad quality, remotely one can do that. And the government of Karnataka has used it for price forecasting for essential commodities 3 months in advance to plan the minimum support prices for farmers. Apollo Hospital has used it to improve the accuracy of predicting cardiac diseases for Indian population. Government of Andhra has used it to predict the probability of student dropout across more than 10,000 government schools in the state. In China, They had the world's first AI news anchor. The AI anchor explained the thinking behind the new technology. Okay, it is essentially mimicking the anchor and same thinking philosophy. AI for Earth. Okay, we all talk about for ourselves in doing that, but for Earth, climate change, good quality, like as you said, sustainable land use, then smart cities, drought planning, water efficiency, cleanliness, smart transport systems, and clean air, weather and disaster resilience. Number of them were Earth definitely desperately needs all these things. Okay. It can be used for rapid molecular design. Want to design a new material for solar energy, a drug to fight cancer, a compound that stops a virus from attacking a crop, or yesterday there was talk about studying the DNA, RNA, protein structures to come up with a new vaccine, how to combat COVID-19. Okay, to analyze this huge amount of data, looking at that, AI can do that by studying the structure. Is starting to make enterprise faster, easier, and cheaper while reducing chemical waste. There is an effort called Benevolent AI, which has raised $100 million to extend AI technology to drug discovery for motor neuron disease like Parkinson's and other hard-to-treat disease. And in June 2018, IBM demonstrated a chatbot that won a debate competition with a human expert without prior training on the topic and proved superior in 1 out of 2 rounds. There was discussion yesterday whether it can write poetry, essays, prose. Duke Literary Journal published an article after review which was written by an AI software. There are many attempts. So when we talk about usage of these things, obviously, like as we human beings are responsible, a responsible AI to augment human ingenuity, it has to be fair, it has to be reliable, privacy has to be ensured, and there has to be inclusiveness, transparency, accountability with social governmental norms and regulations. But later I will tell we can regulate this. But you should not regulate probably AI research, you should regulate AI applications. And regulation should not stifle innovation. Okay, one should not over-regulate this one. When we look at the technology today, one of the main things, as was emphasized, told several times in the context of deep neural networks and other neural networks, that is not able to explain, okay? Lack of explainability. That is where we talk about XAI, or we call intelligible intelligence, okay? That is lack of explainability or XAI. Why he did that? Why he took that decision? See, if you go to a doctor and ask what is the side effect of a medicine, why you should take this, what happens, the doctor explains. But the AI doctor or a software doesn't do that, so you are not convinced, you are nervous about it. Okay, and healthcare, it is certainly very important. It is not that it is not important in other sectors. So if you look at different learning techniques like deep learning, statistical methods, Bayesian learning, and all that thing, if I look at explainability versus prediction accuracy, if you look at something like decision trees, one can get the explanation fairly easy. You say you start from that, 2 paths, binary, go through this search and do that. But accuracy is not. When I go to deep learning, the explainability is not much. Okay, if there is a slight change in the input, what happens and why it behaves like that is not able to explain, but the prediction accuracy is fairly good. So you have this dichotomy. When we talk about AI risk, there are many. Yesterday there was mentioned by both Professor Nitin and Professor Tilak about the fake news, deep fakes. Even during COVID-19, we have heard rumors, and we also witnessed what happened during US presidential elections and many cases. Deep fake, it is hard to differentiate between real and fake content. The interesting part is, if you see, AI is responsible to create some of these things, the AI techniques and all. And at the same time, the AI techniques, learning algorithms are used to fix these problems, okay? Extensive amount of research has been done how to detect fake news, okay? How to detect fake images and fix them. AI techniques are used, and recently it is a sort of exciting area of research. When we talk about AI risk, performance risk, risks of error, risk of bias, risk of opaqueness or black box, you don't know, explainable AI, risk of explainability, then security risks, cyber intrusion attacks, control risk, that is risk of AI going robust, robots won't listen, they will go against you, they will have their own unions, inability to control. Ethical risk, lack of values, value alignment, goal alignment, economic risk. You will say robots will come out, jobs will be taken over, job replacement, but there is nothing to be scared about that. New types of jobs will come. We have witnessed this from industrial automation times, okay? One doesn't know what type of job profile the companies will look for after 5 years, 10 years, 15 years, whether to train robots, repair robots, teach them ethics, what is it? We just don't know. Societal risk of autonomous weapons proliferation, that is where do not weaponize AI. There is a big debate now in different sectors. Should we use AI for mass destruction? Because once it is used, it is going to be very dangerous. Okay, risk of intelligence divide. There are many statements you find AI risks. Okay, like you see. From the Apple co-founder says, the future is scary and very bad for people. Alan Musk, one of the greatest engineers during our times, SpaceX and all that thing we have heard, AI is a demon that is potentially more dangerous than nuclear weapons. Bill Gates says, I don't understand why some people are not concerned. And Stephen Hawking, one of the greatest physicists of our times, said full artificial intelligence could spell the end of the human. Of course, one need not be concerned about all these things, take it too strongly, but generally one has to be a little bit careful about its use. It's not that it's all that dangerous. So we have training data bias, algorithmic focus bias, and there is what we call emergent bias. There are many types, interpretation bias, number of these things, because as was mentioned during the last couple of days, AI applications are certainly data hungry. You need huge amount of data, you have to process them, okay? So if the data is biased, okay, it is given more towards men, less hearing women, ethnic groups, blacks and whites, this may create problem. And most of the algorithms, by study it has been shown that they have bias against race, that is black, white, and women, okay? We will give some examples. Can you trust a robot? Robots must be designed to be trustworthy. There are three major theories of ethics. We don't have time to get into that. Computer science literature, CACM, there are journals like AI and Society are full of papers. If you talk about ethics, how do you develop algorithms for that? And how do you mathematically analyze that? What type of logic symbols you use that? There are famous textbook problems which computer science students are taught, called the trolley problem, the train problem, the Fatman problem, the drone problem, okay, interceptor problem. There are many of these famous problems, okay. There is a trolley goes and it finds in front of it when it's speeding up, okay, there are 5 people are standing. Should it take the risk of killing those 5 people, or if it settles, the brakes are applied, there is a fat man there who will die? What decision should it take? There are a lot of logical studies about that. Similarly, there is an interceptor, there is a drone, and the decision has to be taken whether it should save the human beings or it should kill itself, destroy when the interceptor intercepts. There are many problems. So people have used the notions of deontology, utilitarianism, and virtual ethics. I think Professor Sangeeta Menon is the right person to talk about several of these things, because some of the concepts in a way have been borrowed from philosophy. And deontology expresses morality and ethics in terms of obligations and prohibitions, such as the 10 commandments and the Asimov's 3 laws. Okay, simply you can put laws. Okay, that is, a robot should not harm a human being, a robot should not go against the human being, a robot should protect its interests. Some of the simple laws you can essentially put. Utilitarianism maximizes the quantitative measure of utility. This is again a mathematical concept. You come up with a utility function and try to maximize it. Virtual ethics is like individual learning through experience and practice to acquire values or virtues. A computation method is case-based reasoning, what we use often in computer science, in software engineering, representing knowledge as the cases, if then else clauses, and as a rule-based reasoning can be used. People have attempted, studied these things, and there are many of these examples. An ethical agent must be able to explain and justify the action decisions. Social norms vary by society, so robot behavior will vary. Yesterday there was this question, different things. There are cultural variations, societal variations. So you cannot use the same yardstick, same set of things everywhere. Self-driving cars may well be the first widespread examples of trustworthy robots. Should their design be focused on deadly dilemma or a demonstration of trustworthiness? See, there are a lot of, again, algorithmic issues. We don't have time to get into that. We have what is called a prisoner's dilemma. Two prisoners are put in prison cell. They have to testify, and there are some conditions. If they testify, tell something like that, the punishment will be minimum or they will be free, and one will get less punishment, the other will get more. How they testify against the other person without talking to each other? This is an algorithmic problem studied very extensively in computer science. We have similar to that what is called a deadly dilemma. This is a autonomous vehicle going, you find a pedestrian in front, some people sitting inside. Should you take a decision to kill the pedestrian or cause injury to the people sitting inside? Some moral and ethical decisions must be made quickly online. There is no time to decide, taking a lot of time on these algorithmic issues because online decisions have to be taken. Complex decision for moral and ethical actions involves learning and accumulation knowledge. Okay, that is where learning comes handy. The physical and social environment is immensely complex, posing research challenges. When we talk about AI perspectives beyond the 2020, there are three different perspectives. What we call technology-centric perspective, it claims AI will soon outperform humankind. Human-centric perspective, it claims that humans will always remain superior. Collective intelligence perspective claims that true intelligence lies in the collective intelligence of both humans and artificial. What have been some of the troubling trends with the AI tools? We'll quickly go through. In recent times, if you see, Microsoft's AI chatbot, A, was taken down less than 24 hours post its launch for making sexist and racist statements, again, based on some AI tools. Amazon's AI-powered recruiting tool was withdrawn for not being gender neutral, okay? It was pro-men. Facial recognition tool in China wrongly shames a billionaire businesswoman as a jaywalker. IBM's Watson used for oncology diagnosis withdrawn after spending $62 million and finding unsafe treatment recommendations. Some of them very dangerous recommendations. In London, a face recognition algorithm to detect criminals labeled suspects only in 19% of the cases. Google in Atlanta exploits homeless Black people for buying their images for training. AI system has been fooled into misleading a stop sign by positioning 4 rectangular stickers at the post. When people were doing experiments for an autonomous vehicle, driverless car, you have to have a stop symbol. So they manipulated 4 rectangles in a nice manner, pasted on that, so that it took as a stop symbol there. Okay. Speech recognition systems have been tricked into hearing phantom phrases by inserting patterns of white noise in the audio. Image processing software identifies a different object if few pixels in the input image are changed. It is very difficult, in fact, tricky. In future, you will find hackers could hijack the neural nets in the cloud to run their own spam bot dodging algorithm. So we do create problems. A robot DNN should not change its output as a result of small changes in its input. DNN should be combined with symbolic AI. That's what people say. It is not one, but use some hybrid things to see whether you can improve that. Instead of learning 2D, maybe 3D environments, real or simulated should be used for learning. In future, machines will manipulate the world and create their own scenes through their own action. Learning about causality needs to be done by agents that do things in the world that can experiment and explain. Okay? Some of it was explained yesterday very nicely by Professor Nitin. AlphaZero's algorithm can be trained to play with Go and chess, but not probably both at once. So in deep learning, if something doesn't work, it is difficult to figure out why. Explainable AI or intelligible intelligence is the need of the hour. The most advanced AI systems are primitive when it comes to interpreting complicated images or video with all the claims we make. There are startups like Otter, Sonix, Temi, and Trint who provide offline services. They take the digital audio files, generate transcripted documents from that. Even this year, if you see the scenario, a startup like Temi claims that no better than 95% of the recordings are clear for unaccented speech. Even 5% error is something which cannot be tolerated when you want to report news and write something from audio to transcript. Okay. In 2015, programmer Jack Alcine and his friend, both black, were labeled as gorillas by Google's Google Photo app that uses machine learning. Compass, which is used for criminal justice, whether a criminal comes, whether the bail has to be given. For that, one has to find out, the judge has to find out what is the probability that the criminal will repeat the same offense in future, okay, to decide about the arrestee's eligibility for bail. The tool was found to erroneously predict based on racially biased patterns. Predictive policing system PredPol produces outcomes that are biased against black people because of biased training data. Real-time facial recognition systems in body cameras, they're used in police where they have to defend themselves. Sometimes police encounter criminals. We have heard some stories even in India. There are encounters. The blame is on the police that knowingly they have killed. So if you have a body camera, probably it can act as a proof. Because there is no other proof you can have, okay? It can be saved and interpreted, but that also has created some problems in some scenarios. AI for criminal systems should be open for scrutiny. In hospitals in the University of Chicago, University of California, Berkeley, healthcare algorithms have shown racial bias, and the algorithm had inputs such as zip code. So the moment you give zip code, from that it can find out which is the affluent neighborhood, and which is something like in Indian context, probably a slum area. Predicted value of healthcare cost based on past data. This is something very important because IBM has estimated that an average person will generate 1 million gigabyte of healthcare related data in her lifetime. So huge amount of data will be created. It has to be used very carefully. In China, a deepfake Zhao can superpose any face onto those of actors like Leonardo DiCaprio and Marilyn Monroe. Facebook challenge, many of you would have heard. Facebook has now announced a challenge. Of course, the last deadline might have been over. US $100 million for developing a robust deepfake detector, and DARPA's forensics program are efforts to detect deepfake. Facebook disabled 1 billion fake accounts. Its security team has developed to double to more than 20,000 to handle content in 50 languages because of this problem. And you have heard about fact check and all these things, what we find in TV. Facebook revealed that Russia's propaganda machine had reached 126 million users in ad campaign during last election. During last campaign, the largest Trump Twitter botnet consisted of 994 bots, compared with 264 bots for pro-Clinton botnet. AI systems don't pick up on subtle clues, ambiguities that a human doctor does that. IBM's Watson, which won games and all that, it did excellent thing, provided useless and sometimes dangerous recommendations for oncology treatment. University of Texas spent $62 million for a cancer center before cancelling the projects due to failure in oncology projects. Algorithms wrongly label black defendants as future criminals at a rate twice that of white defendants. Only 20% of the predicted violent criminals were actually so. In legal practice, humans can be swayed by emotion, can get tired. Machines do not have contextual considerations. For example, how a sexual harassment case has to be dealt with, a machine cannot look at some of the contextual and sensitive issues when you put it for an AI judicial decision, but whereas a human judge can do it. Machines will not lecture a defendant to set his life right. Humans have to issue the final verdict. So in legal profession, the claim is it has to be both. Now, all these things coming towards, are we really heading towards another AI winter? Possibly not, but there are concerns. Machine learning efforts should run in the same way as software development process, encourage documentation, code development. A very recent study of 40 AI startups in the USA did not demonstrate a promising profitability pattern of these companies. Many healthcare models may be statistically accurate but not clinically useful. Most doctors, even in the US, have felt that. Do not regulate AI research, as I said, regulate AI applications. Regulations should not stifle innovation. There is, one has to keep in mind, there is no killing, that is important. Responsibility, transparency, privacy, bias are important. When mathematical and natural language statements are mixed without clarity, both the prose and theory suffer. So one has to be very careful about this mathiness. Bias is considered to be a disproportionate inclination and prejudice for or against an idea or a thing. It's often thought of in a human context, but can exist in many different fields. Bias in AI mainly occurs in the data or in algorithmic model. It is critical to develop and train the systems with the data that is unbiased. So AI expert calls for end to UK use of racially biased algorithms. That is, algorithmic bias is bad, uncovering it is good. AI bias could put women's lives at risk, a challenge for regulators. Okay, there are many claims. So there can be what are called declarative bias, prior beliefs and assumptions about the space of things possible to learn. Statistical bias, that is systemic difference between the calculated value of statistic and true value. Cognitive bias, stereotyping, prejudice. We will give some examples, different kinds of bias to AI. The Georgia Institute of Technology indicated that autonomous vehicles might have a more difficult time detecting pedestrians with a darker skin, okay, because the training algorithm was done so. Those cars were programmed mostly by young white male engineers, so the systems were 5% less accurate when recognizing people who have darker skin than those with lighter skin. We have what are called bias to interaction. The professional networking site LinkedIn was discovered to recommend male variations of women's names in response to search queries. When you use per job vacancy, job profiling, when you give a female name with something possible matches for jobs and all, it tried to take the nearest possible male name and came up with the match of jobs. For example, you give a Stephanie, it took it as Stephen and came up with the type of matching job. The site did not make similar recommendations in searches for male names. The company said this was the result of analysis of users' interaction with the site. Amazon tried to use AI to build a resume screening tool to make the process of sorting through job applications. It built a screening algorithm using resumes the company had collected for a decade, but those resumes tended to come from more from men. That meant the system in the end learned to discriminate against women. A recent research article in Science has showed that an algorithm widely used for population health management to predict which patients will benefit from extra medical care has a significant racial bias. It dramatically underestimates the health needs of the sickest Black patients. The magnitude of bias is large. Removing it would more than double the number of Black patients eligible for a program that gives extra medical help. There is a Paul's drug crime prediction algorithm was trained on data that was heavily biased by past housing segregation. So it would more frequently send police to certain neighborhoods where a lot of racial minority lived. Arrests increased there and arrest data was fed back, so it would predict more future drug arrests in those areas. And it was like a positive feedback action and send the police there again. So there are many types of human biases. We don't have time to get into that. There was talk about the language translation. translating sentences from a gender-neutral language such as Hungarian to English provides a glimpse. You have at the bottom, you see in the screenshot, there is a translation. There is a Hungarian sentence on the left side. On the right side, you find that this is a gender-neutral language. So what happens the moment it came with the word something like a nurse, it always went towards women. She is a nurse. If it is a scientist, even though it can be a woman, it translated is he is a scientist. Okay, engineer, he is an engineer. And when it's a baker, it always attached to a woman, she is a baker. Okay, teacher, he is a teacher. If it is a wedding organizer, she is a wedding organizer. If it is a CEO, he is a CEO. So there have been many of these biases like this in language translation. One can see that adjectives such as shy and desirable, sad and dumb amass at the female side of the spectrum, contrasting with proud, guilty, cruel, brave, which are almost translated with male. What you see on the right side, the simple picture, different words, and whether they are attributed more towards men, more towards women, or more towards more being neutral, okay, by taking types, okay, which is sort of biased translation. That is why Google Translate included a new feature presenting user with a feminine as well as a masculine official translation. It says she is a doctor, he is a doctor. There is a translation from Turkish to English, okay. It gives both the provisions. So how are you going to define and measure the fairness of the impacts of outcomes of the AI systems you are developing? Okay, there are many different formalisms of definitions of outcome fairness. We don't have time to get into all the thing. An outcome is fair if each group in the selected set receives benefit in equal or similar proportions. That is, if there is no correlation between a sensitive or protective attribute. You, in a bigger group, you take subgroups like we said, men, women, urban, rural, the black, white, some of these things, and see how they are benefited. So depending on that proportion, you talk about different types of fairnesses. We talk about group fairness and all that thing, okay? And you can evaluate for fairness inclusion, come up with what is called a confusion matrix. We have a reference data input given. We get the model predictions, what we get from the algorithm, because we want to see whether the algorithm is fair or not, okay? We have this 2 by 2 matrix, which gives positive, negative, positive, negative. We have what are called, it is false positive, false negative, okay? That is positive, existing, predicting, true positive. You have false negative, false positive, true negative. So for an algorithm, one comes up with this and does some analysis. So choose your evaluation metrics in the light of that, come up with false positive, false negative, and all the things. And by and large, you try to develop, it is pretty tricky. You have something so that the false positive, false negative are somewhat little bit equal. Of course, you cannot get a number like 1, 1, okay? There are a lot of algorithm studies on that. So what should we do? Drive straight and run over a baby or swear and hit the 2 pedestrians? The autonomous vehicle has this problem. What if one of the pedestrians is your mother-in-law, okay? So when you talk, there are many attempts. The European Commissions of Ethical Intelligence Trustworthy AI include checklist of questions about bias. Google AI, in conjunction with AI principles, has published set of recommended practices. Microsoft has released guidelines for conversational AI bots to treat them very fairly. IBM has come up with a tool, which is public domain, AI Fairness 360. So it is an open source tool. You can take it, feed your algorithm, feed your data to that, it analyzes and comes up with some fairness metrics. There is another tool called what is called Equitas, an open source bias audit toolkit for machine learning developers, analysis and policymakers. It is developed at the University of Chicago. And we have AI fairness tool. You can take the algorithms, raw data, do all that thing. We don't have the time to get into that. We have what is called a fair test. So there are tools available. And there is an interesting work. Some researchers from IIT Delhi have done something attribute-aware filter drop for bias invariant classification. So if you have some data which is creating this bias, it can be detected and the filter coefficients can be dropped in the neural networks, okay? This is called filter drop. You can go forward, you can see the figure, bias, the covariant ethnicity. There is something related to ethnicity. So that aspect can be dropped. You have a simple mathematical equation there. MFI is 0 or 1. Then the filter coefficient is set to 0 or 1. And there are n filters there. The one which is creating trouble can essentially be manipulated. Like you have this biasing, blacks are homeless, then Asians are laborers, Jews are greedy, and when attaching with that, right? So solutions for bias is like cooperations with humans and raise the awareness and the transparency. Okay, we will quickly talk about a couple of issues, then conclude. There are areas of automation. AI raises some issue like it will prove jobs, you will have problems. In the 19th century, we had machines taking away dirty and dangerous jobs, but people were not thrown out of the industry. 20th century, machines take away the dull and automated interfaces. 21st century, machines take the decisions. So we will have new types of jobs created. There is nothing to be really concerned. If you look at the technical automation potential studies, there are a lot of jobs. About 60% of the occupations have at least 30% of their activities that are, which can be automated. So obviously, AI tool can be used there. This essentially tells to what extent jobs can be automated. People will be using. And the impact of AI and employment in India. People have studied agriculture, manufacturing, teaching, communication, transportation, and it is found that by introducing these tools, the number of jobs in some sectors will increase. Okay, this point shows that. So societal risks are unemployment, distribution of wealth, impact to human interaction, machine makes mistakes, bias, breach of security, singularity problems. Okay, and will we run out of jobs because of AI? No. Technology is there to solve problems. Are we out of problems? A big no. As long as you have problems, there are jobs. AI will help you create jobs. And this is what we said. If there is a fatality thing, whom do you blame? Okay. Only thing is, you should not make the machines act like men, okay, or human beings. In this case, it said there is a driverless car. I thought this car could pilot itself. It could until it started texting. Okay. So there are many surveys about what will happen in future. 500 participants from philosophy and theory conferences, top AI researchers were asked. They said maybe probably more than 50% will reach overall human ability by 2040, 50. Very likely 90% probability by 2075. Will move to super intelligence in 2 years. 10% only said. And by 30 years, that is more than 75% said, it will be only a distant future. 76% of the CEOs are most concerned with the potential of bias and lack of transparency when it comes to AI. Okay. So ethics seeks to resolve questions of human morality by defining concepts such as good, evil, right, wrong, virtue, vice. AI research needs to base itself on a sound understanding of the various implications of any innovation. Bigger threat is the misuse of algorithms by hackers to develop autonomous techniques that jeopardize the security. That's where I make this statement. Natural stupidity is more dangerous than artificial intelligence because we develop algorithms, we feed the data, we talk about applications, where to be concerned, okay? Deep learning algorithms that are opaque to users could create hurdles in domains such as healthcare, where diagnosis and treatment need to be backed by a chain of solid reasoning. Like a doctor explained the side effects, the AI should also tell that. AI algorithms might by design inherently subject to errors, for example, citizen profiling based on demographic things, color, gender, and all. AI system actions should be transparent. They should be transparent, operations visible to user, credible, outcomes are acceptable, auditable, that is, efficiency can be measured, reliable, that is, perform as intended, recoverable, manual control can be issued this way. Like knowing the side effects of medication, gaps of AI should be known. Okay. Satya Nadella says the most critical next step in our pursuit of AI is to agree on an ethical and empathic framework for its design. So a lot of work has been done in emotion, sentiment analysis, emotional analysis, Learning algorithms, AI techniques have been used. There are companies like you find in West Coast in USA, a company called Emotion. People have used it for even commercial applications. You go to a shopping mall, look at a product, you are happy. There is a camera. Without your knowledge, it takes your image. So the way you shrug, you use your eyebrows and lips and facial expression, it finds out whether you are happy or not. Okay. And the future robots probably should have some such feeling when they're used for patient care. Yesterday, there was a question about IEEE standards. IEEE ethically and AI design, there were a large number of standards, 7,000, 7,001, 2 standards for model process, standard project for transparency of autonomous systems, data privacy, algorithmic bias, number of ethical bias consideration. IEEE has come up with standards. And in AI, cybersecurity also something which is an important thing. Artificial intelligence has the ability to take intelligent decisions, but it is absolutely imperative that cybersecurity of AI should become an important priority because hackers should not create some problems by hacking these things and committing undesired actions. Alan Musk said, nobody likes being regulated, but everything, whether cars or planes or food or drugs, that's a danger to the public is regulated. So AI should be regulated too. Okay. Standards and benchmarks can be effectively used to get progress in AI innovation. Investments in AI research should be directed, keeping in mind multiple aspects that come together to deliver commercial or social field. The design philosophy must be such that it ensures security against external attacks and evaluate the current educational pathways and curricula if required overall this interdisciplinary aspect which was talked about yesterday, and those should be taught. AI development will need the involvement of experts from computer science, social, behavioral science, philosophy, psychology, ethics, biomedical science, legal aspects, economics, law, policy research, number of them should be. India has come up with several reports, National Strategy for AI, that is AI for all. They have come up with some conditions for responsible AI strategy, talking about Centers for Research Excellence in AI, International Center for Transformational AI, how it should be used, what are the important sectors like healthcare, agriculture, transport, infrastructure, some of these. There are many projects which handle these. There have been some bold predictions. One has to take them with a pinch of salt. By 2023, AI techniques will be primary method for significant discoveries in life science. By 2025, the first national or subnational government will ban human-driven vehicles. 25 to 28, AI will demonstrate creativity by producing a global blockbuster film. Maybe a few more further years down the line. The interesting facts, if you look at, analyze, you see, as I told you, the responsibility in a way is on us. We invented fire, repeatedly messed it up, then invented fire extinguisher, fire executor, fire alarm, fire department. Just as most chemists and biologists have no interest in building chemical and biological weapons, AI researchers have no interest in building AI weapons. The fear of machines turning evil is another red herring. The real worry is not malevolence, but competence. A super intelligent AI is by definition is very good at attaining goals, whatever they may be. So we need to ensure that its goals are aligned with ours. That the first ultra-intelligent machine is the last invention that man need ever make, provided that the machine is docile enough to tell us how to keep it under control. In fact, many of you would like to go through a book, Max Tegmark, a professor at MIT in physics and AI. That is Life 3.0. He has written Life 1.0, 2.0, 3.0, which talks about being human in the age of artificial intelligence. Okay, very interesting reading. To conclude, a framework is needed to ensure that AI behavior for humans is implemented through a set of logical constraints and AI system behavior. Relevant professional ethical principles should be practiced. Of course, ethics, bias, some of these issues to study detail algorithms is pretty hard. A lot of research is going on. You can find even quite a few theoretical papers, algorithmic papers. Research efforts must be concentrated on implementing regulations in AI system design that are updated on a continual basis. And there should be money or funding for ethical AI research. For example, machine intelligence research, MIRI, US Army Research Office, Google have committee. They spend money on ethical AI. Okay, hope this should not create some panic. Probably sometimes we are worried whether such a thing will happen, but I think we need to take control in that. Thank you very much.
Thank you, sir. That was a very excellent presentation, very informative. Sir, we have already some couple of questions and comments. So
Okay.
let us move on to the questions. So first question is
Okay.
from Dr. Shailaja.
Yes.
So ma'am, could you turn on your video and give a brief introduction about yourself and ask the question? Are you there, ma'am? Okay. Okay, then yeah. I will read out the question. Professor Patnaik, since AI algorithms learn from massive amounts of naturally occurring data, will they not naturally, okay, one second. Will they not naturally reflect the real world? How can the AI recommendation be artificially corrected in any meaningful way? Example, if it is recommending a certain socio-economic class, say to a bank giving loans or providing loan risk guidance based on studying millions of loan precedents, why would the customer want the recommendation to be tweaked? I would like to hear your views on this, if possible.
Sir, you're muted.
Yeah. Sorry, someone has muted me. Okay. Okay. Yeah. So the first question is from Dr. Shailaja.
Are you able to hear?
Yeah, we can hear you, sir. Yeah, yeah.
Okay. I have not muted myself.
Okay, okay. Yeah.
Yes.
So I'll read out the first question.
Yes.
So we've heard your question, Hari.
We heard your question, Hari. Yeah.
We heard your
okay,
question.
okay. Okay, great, great.
Yeah. See, the point is, it is intentional somebody is doing. You are asking why would somebody like to do? The data is given while training. I talked about different types of biases. Okay. It is intentional. You try to give data in such a way while training that the decisions are given more towards that. And when you look at the accuracy at the end, final classification or decision, the percentage turns out to be more. So you prefer that particular group or that particular class when you talk about a loan being given to some class or some group. Okay. So when you have fed the data, given the data is biased. Okay. That is where we are talking about techniques and methods, how to remove that, the biasing in the data so that it is unbiased and fair.
Thank you, sir. The second question is from Sarmishta Dhar. Ma'am, if you are here, could you give a brief introduction of yourself and ask the question?
Yes, sure. Am I audible to you?
Yeah, you're absolutely
yes.
audible. Yeah.
Yeah, you listed in, I'm Shormishta Dhar. I have done my PhD in philosophy from Jadavpur University, and at present I'm working as an assistant professor in philosophy at Diamond Harbour Women's University, West Bengal. My question was in one of your slides. It was a very illuminating presentation, and I learned a lot. Thank you, Professor Patnaik, for this wonderful presentation. And
Thank you.
In one of your slides, you enlisted as one of the drawbacks, one of the flip sides of the abundant and inordinate dependence, reliance on AI, singularity. And I didn't quite understand that part. So could you kindly explain that?
Dependence and singularity, I don't think I said so. I just talked about singularity. Okay. There is no question of singularity. See, superintelligence or singularity essentially addresses the issue of machines being as intelligent as human beings or more intelligent and taking over the human beings as far as intelligence and capability is concerned. Because the prediction, the argument is with the advances in computer hardware and software, where machines become more and more powerful. As you can see, Watson has beaten the chess player at some of these, in other games, people conceded defeat. because they were supercomputed. Most powerful machines could execute the algorithms pretty fast. So the fear is, if you have this type of message, maybe they will overtake human beings. Okay, that is the concept. We are not going to depend on those things. The concern and fear is, will they be equal to us? Will they overtake human beings? If they overtake human beings, are embedded into robots and some of them, because as is being told, I think in future a day will come when in offices maybe 50% and more than 50% working group who will be sitting side by side with you are robots. Okay, and a webinar like this may be even heard by them, and they will be participating, and maybe a speaker also may be a robot. Okay, so when we have scenarios like this, the question comes: will they listen to us? If they are very powerful, they are equally powerful, more powerful than us intellectually, what will happen? So that is the concern. Did I answer?
Yes, sir. Yes, sir. Thank
Yes.
you. Thank you.
Okay. Thank you very much. Thank you.
Thank you, sir.
Yes.
There are a couple of comments from Dr. Pushpa Srinivas, very inspiring talk detailing various facets of AI, positive and negative. Ultimately, everything in life has to be used properly for better results. Thank you. And then, and then another from Ranjana Yadav, assistant professor. Thank you so much, sir, for your informative presentation. Due to your presentation, my doubt related to AI has been cleared. Yeah. If there are any further questions, could you kindly...
There's a question by Nazneen Aisha, right? You could ask her to...
Yeah. Could you kindly give a brief introduction about yourself and ask the question? Nazneen Aisha?
Hello,
okay.
Sir.
Okay.
It was a brilliant presentation. Thanks a lot, sir.
Thank
So my
you.
question is with regard to the role of AI in gender. When we come to gender studies, we often come across the model of cyborg and so on. And do you think it will help us to erase, to some extent, the gender inequalities that exist in our contemporary society?
Yeah, this is again, madam, a decision-making process. I gave you some examples about bias. I told you in the job profiling, job selections, hiring patterns, okay, what some of the chatbots and companies are using. As you can see from all these things, it is because of the data we are feeding the algorithm, the way it uses, the algorithm uses the data, right? When we talk about the decisions, okay, gender inequality, biasing, okay, it's again, we do it. By that we, I don't want to precisely tell who, okay. We take the decisions, come up with certain norms, okay, take decisions based on that. So at that stage, we need to arrest and take some corrective actions. That is where people have been working on this, how to eliminate, remove bias from this. I gave you example of one particular paper which talked about, in fact, we should go through that paper written by the IIT Delhi authors. It talks about gender equality, ethnicity, some of these things. So wherever they suspected these problems are there, it detects which filter, which corresponding stage is responsible for that, and they make those coefficients zero. Okay, there is fair amount of algorithm, theoretical analysis, study which has been done. People are concerned about that. Yes, it is possible, it can be done, right? When you talk about this gender equality and taking decisions impartially for many roles, operations, and all that thing. At the end of the day, as I said, we develop algorithms, we choose the data, we feed the data, okay? Machine doesn't automatically choose that. So you have to choose the right type of data, develop right type of algorithms, okay? All these issues have come up due to our own making, in a way, I would say. So we should correct it. And if it cannot be, part of it can be done automatically. You can develop an algorithm to detect the algorithm bias itself or the data bias itself. That is what people have been working on. Did I answer?
Thank you, sir. It is very clear.
Thank you.
Thank you so much, sir. Sir, we are running a little short of time. So I would now request Hari Krishnan to give an official vote of thanks. Followed the process is that we'll make some announcements regarding the feedback forms. And also I would then request Dr. Nitin Nagraj to give the official vote of thanks for the workshop. So Hari, over to you.
Yeah, thank you, Niharika. First of all, I would like to thank especially two main people like Professor Sangeeta Menon and Dr. Nitin Nagraj for organizing this workshop, this idea. So in this workshop, actually, we learned a lot. We tried to connect different aspects from AI to ethics to fairness, bias, technological aspects. So we learned a lot in this workshop. So my thankfulness to all the people who are like behind this workshop. Secondly, I would like to thank the coordinators, Niharika Sharma, Aditi, Ashwini, Abhishek, who are like always there for us, like for the workshop. And thank you very much. And also, I have seen that some of your questions are there, so this will be addressed to you via email. So to all the participants, thank you for your excellent participation and asking very wonderful questions, and which has led to more discussions. Thank you very much. So I would now like to invite Dr. Nitin Nagraj to give final word of thanks.
Yes.
Yeah, thank you.
So first thing I think I should mention is Professor Patnaik has actually been a pillar of support for us, I mean, when I told him about the workshop, he was the first speaker to actually accept our invitation, So thank you very much, sir. And it was very, very illuminating. And I think you touched upon, although you said that all the three speakers have already spoken everything, that's not true. I think you brought in lots of new ideas, new facets, new points of view. And I think that's very, very invaluable. So I think I should mention that. So thank you, sir. Now regarding the workshop itself, as I said in the first day yesterday, that the idea actually was Professor Sangeeta's, and I think, without which this wouldn't have happened. So thank you, Sangeeta, for that, initiating the whole thing. And then I think the three speakers, including me, when we tried to do our best, but I think thanks to all the questions and discussion which the participants brought in, it added, I think it made it much richer. And I know that we have not addressed all the questions so far, but hopefully we can promise all the participants that please email us and we will get back to you with the best we know. We obviously know very little, and whatever we know, we can share it with you. Now, as even Hari said, there are a lot of people behind the scenes, who silently work and who never show up in the front. So I think we should thank them. I think Ashwini and Niharika especially, I think they did a lot of groundwork. I think without them, none of this would have actually really happened at all, So thank you, Niharika and Ashwini. And I think Abhishek as well for helping us with the poster. And thanks to Aditi and Hari for, moderating some of the sessions. But of course, last but not the least, I think the participants, I think because of you, I think we were able to take up these challenging topics, very, very challenging, very complex topics. And I think many of these questions are giving us an idea as to what next we should follow up with, right? So thank you very much. And please be in touch with the speakers and with NIAS CSP team. So thank you all, and back to Niharika. Yeah.
Yeah, the feedback forms will be emailed to you by this evening. It is like a short feedback form for each session, and also there's a column for your participation certificates also in it. So I would just like to highlight that 19 July will be the last date to submit your Google feedback forms, and also by 20th July the team will be able to give you all the participation certificates for all those people who have emailed us already and who will be ticking their answers in the Google form too. So, ma'am, Sangeeta ma'am, would you like to say a few words to conclude the session, or?
Thank you, Niharika, for asking me. Well, I didn't want to say anything, but we are truly grateful to people like Professor Patnaik, who everybody respect and adore. And I see in the chat box itself, there are comments by people who were your students. Like I think Mr. Narayana has written that he was your student in the 80s.
Yeah, yeah, he has held very top position in TCS. He was a vice president in TCS.
Okay, okay. That's wonderful to know.
Thank you, Ms. Narayana.
Yeah, so we are very grateful to you, Professor Patnaik.
Thank you, Patnaik. Sorry.
He's a great friend and supporter of our program and all of us. He's a continuous inspiration for us. And we all admire his ability to say things which are so dense and complex in a very lucid manner, which everybody can understand. So it's really great. I'm just adding a couple of lines. I think Dr. Nitin has already done a lot of lines. And I think we wish to continue this.
Thank you, madam. Thank you, madam, for your nice words. Okay.
Thank you, sir. So we wish to continue this series of workshops in the months to come. So we will be discussing behind the stage and we will be back to you. And Niharika Sharma will be making some announcements now. But before I think I stop, I should say that Niharika Sharma was the one-person army to put this together, because I know the amount of work she does. And the videos are uploaded. She was late awake in the night to make sure the videos are downloaded so that we have the space free for this morning to record these 2 lectures. So that kind of commitment from a research scholar is not very common. So perhaps all of us will imbibe those qualities from Niharika Sharma.
Thank you, ma'am.
Thank you.
Thank you. Everyone get an email for their feedback forms by the evening. And please stay in touch via our official email, NIAS ESP program, NIAS consciousness program @nias.press.in. Please email us. Please visit our website. We are also organizing our upcoming workshop in August and also in September. And I will also email the personal email IDs for all the speakers of this workshop. So please stay in touch with us. And thank you so much for your presence. And thank you for making this workshop a success. Thank you, everyone. Thank you, Patnaik sir. Thank you, Sangeeta ma'am.
Thank you very much.
Thank you.
Bye.